Okay, year 13. How to integrate trig functions. How sexy is that? All right, now I'm just drawing your attention to the fact that there's a very useful table of trig derivatives and integrals on page 351 in Delta. You have access to this Delta book in Teams, okay? And but when you open the electronic copy, you will maybe find that the page number, it doesn't match. It must be somewhere around about the 350s, okay? But sometimes the electronic version page numbers don't sort of match exactly the real book page number. Okay, now I don't really want to explain any of this except by getting stuck straight into examples. So that's exactly what I'm going to do here. I'm going to start example 1. Okay, so what you've got here, you've got to integrate the cosine of 7x dx. This 7x, of course, is an angle. So what you do is you say let the angle, let it be u, equals 7x. You differentiate. Du by dx is 7, so du is 7 dx. We've just cross-multiplied this dx up there, and we can write that du is 7 dx. Now, if I now pre-multiply this dx by 7, which I've shown you here in red, then I will have altered the value of the integral. So I've got to keep the value of the integral the same, and the only way I can do that is to divide by 7 at the same time. Okay, so bring that 7 in front of the integral sign. There it is, 1 over 7. And now your integral becomes something that looks much easier, because this 7x is now u, and this 7 dx, which we found here, is now du. And of course, this cosine of u is a derivative. The derivative of what function? Well, you should know that by now. It's sine. So you do the integration. It's 1 over 7 times the sine of u. Put the u back as 7x, and there's your answer. Not that hard. Okay, let's do another example. This is example 2. Looks pretty horrible, but don't be alarmed. Take the minus 2, which is a constant, take it outside the integral sign. I always do things like that because it makes the integral look even more simple. Okay, now we do exactly the same thing. We let u equal 5x. So du by dx is 5. Cross multiply the dx. Du is 5 dx. So we're going to pre-multiply the dx in these things here by 5, as you can see here in red. So I've multiplied it by 5, but I have to keep the thing the same value. So I've got to divide by 5 at the same time. Bring that 5 before the integral sign. There it is. So we're going minus 2/5 integrating cos u du. The du, of course, is the 5 dx, and the 5 dx is u there. So again, it's nice and easy. A nice, easy integration, because cos u is the integral of sine u. And so we can now say the final answer is minus 2/5 sine 5x plus c. Okay? All right, let's move on. Oh, yes, I have to come down with the zoom on this one and I have to go to the next page, and then I have to resume this thing. Yo. Okay, I think that's all right. Now then, let's go and look at this thing. All right, now this is an integration using of sec squared, but it's got an x there and it's got stuff here. It's difficult. It looks really horrible. But if we stop and think about it, it's something to do with sec squared. We should know that sec squared is the derivative of tan. So maybe this is not so hard after all. Let's see. Okay, well, what you do is you say, let this 3x squared minus 1, let that be equal to the variable u. Differentiate. Du by dx is equal to 6x. And then cross multiply the dx up here, and we get that du is equal to 6x dx. Now this time, there's an x involved. What are we going to do now? Well, look at the original function, integrand. There is an x at the front, and we're going to use it. We're going to, not only are we going to pre-multiply the dx by 6, we're going to bring this x, this one there, we're going to bring it together with the 6 dx. Now don't forget, we've got to divide by 6 as well, so I'm going to bring that to the front. There it is, 1/6. Now, look what we've got. We've got 1/6 times the integral of sec squared, this thing, 6x dx. Now this 6x dx is du. This 3x squared minus 1 is u. So the integral becomes sec squared u du, which is so easy to do. So when we do that, we should know, of course, that sec squared u is a derivative of tan u. So I've done my integration, but it's now multiplied by 1/6. So the final answer is 1/6 tan of 3x squared minus 1 plus a constant of integration. All right, now let's look at the next example. This is, again, looks pretty fearsome, but we'll use our usual technique and see how to do this. Well, I've taken the -8 outside the integral sign. Now this could be a little bit tricky because if I left the minus sign inside, it would help later on, but I haven't done that. I've taken it with the with the 8 outside. So we've got -8 outside the integral sign. It's not a problem if we're sharp. All right, so let's try and stay sharp. So what have we got left? We're integrating the sine of 16x dx. Well, let u equal 16x, du by dx is 16, du is 16 dx, the usual stuff. So we're going to pre-multiply the dx by 16. Well, we've got to divide it by the 16. So bring that 16 being divided outside the integral sign. So we get -8/16. What have we got left? Well, we're integrating sine u du. Now, this is where you've got to be sharp, because what we're integrating here is positive sine u. Now, that's going to be a derivative. Well, when you differentiate cosine, you get minus sine. So if you integrate positive sine u, it must have come from negative cosine. Okay, so when we integrate positive sine u, we're going to get negative cosine u, and that negative there and that negative here are going to go positive. Now, had I taken this minus sign, like imagine that's -1, had I taken it back into there and integrated minus sine u, it would have gone straight away to positive cosine u, and that would have been a positive there, because when I took the -1 there, they would have been left with +1/2 there. So yes, had I left that minus sign with the minus sign 16x, then I could have done it straight away and got positive stuff. But we remain sharp and we did it. Okay, all right, now I think I'm going to stop the video now, because I'm going to go on to example 5, which is a super sexy one. Okay, it's really hard, but if you can understand example 5 on the next video, then I'm sure you will have learnt an awful lot. Okay, it's just that I'm running out of recording time.